Welcome to writing equations of transformations. Our essential question is, how do we write the equation of a transformation? Example 1, we want to write the equation involving the following transformations of the parent function f of x equals x squared, our quadratic parent function. And then we want to graph it. So first thing up, our vertical stretch has a factor of 2 with no reflection over the x-axis, horizontal shift of 3 to the left, and vertical shift up 1. So our a value is 2, c, horizontal shift of 3 to the left, is -3, and d, vertical shift up 1, so that leaves us with a d of 1. And b, which was not mentioned in our transformations, is therefore also 1. So now we're going to plug into our general formula. Our a value gets multiplied by the function with b times x on the inside. Take away our c value, adding d at the very end. So just substituting into that formula, the a goes in front, so 2 goes here in front. B, which is 1, gets multiplied by x. Take away c, which is a -3. This is all being squared because that is our parent function. And then to the end of that, we are going to add our d value, which is 1. Now we simplify. 2 parentheses 1x, that's just x, minus a -3 becomes +3, squared, plus 1. So now we have our function, and now we're ready to graph. Over here you see our parent function already here. This is y equals x squared, the parents. Now let's graph the child. And our vertex is going to be located at -3, comma 1. So 3 to the left and 1 up. So left 3, up 1, puts a point here. Our child also has a vertical stretch of factor 2, so that means it's going to be rising twice as fast. So it's going to be skinnier and taller. And now we have a sketch of what our new function with its transformation looks like. So we'll pause, copy the notes, and then we will continue on with example 2. Okay, for example 2, we now have a parent function that is absolute value. We have horizontal compression of 2 with reflection over the y-axis, and it's also shifted down 5 and right 4. Now, just a note, vertical stretch is when a is greater than 1. Vertical compression is when a is less than 1. Horizontal stretch is when b is less than 1, and horizontal compression is when b is greater than 1. What you should notice, hopefully, is that vertical stretch and horizontal compression basically do the same thing. So these two are very similar to each other in their impact on the graph. If you stretch it vertically or if you compress it horizontally, you end up with the same result. Vertical compression and horizontal stretch also give you the same result as each other. So, just a little side note. Alright, so from this particular problem, we know we're doing absolute value, so I've got them set up in the problem. Horizontal compression of 2, that's my b value, and they tell me that it's being reflected over the y-axis, so that's a -2. Shifted down 5, so d is -5, and c is right 4, so +4 for c. A is not mentioned, so a is 1. So let's go ahead and substitute into our formula. A is 1, so you're going to have a 1 out here in front. B is -2, so we're plugging a -2 in here with the x, minus c, which is 4, plus d, which is a -5. So if I simplify that, I end up with absolute value of -2x minus 4 plus on negative 5, otherwise known as just minus 5. So my new function is the absolute value of negative 2x minus 4, take away 5. So now if I graph this, this is where you have to kind of be aware of what's going on. My vertex of this appears to be at 4, negative 5. So when I go over 4 and down 5, it would be here. But the b value being negative 2 tells me that I have to have a reflection over the y-axis. So that means that this point right here is actually going to end up on the other side of the y-axis. So it's going to be reflected over here. Okay? And then we have a compression of 2, which means that, or horizontal compression, which means that it's getting squeezed sideways. So again, a horizontal compression is very much like vertical stretch. So it is going to be growing or going vertical twice as fast. If you're compressing it from the sides, then that means it's getting skinnier. And so it will be a little bit skinnier than its original parent. But the key to this, again, is that negative 2 for b means that my entire graph got flipped over the y-axis. And so it now ended up over here mainly in the third quadrant. Right, go ahead and pause, take complete example 2, and then that's it for your notes. Have a good evening, have a good weekend. We'll see you on Monday. Bye-bye.